Carbide burr tools, also known as carbide burrs or rotary files, are essential high-speed cutting instruments widely used in metalworking for deburring metal parts. Deburring involves removing sharp edges, burrs, and protrusions left behind after machining processes such as milling, turning, drilling, cutting, or grinding. These imperfections, known as burrs, including Poisson, rollover, and breakout types, can pose safety hazards, interfere with assembly, affect dimensional accuracy, and reduce the aesthetic or functional quality of the part. Carbide burrs excel here due to their exceptional hardness, made from tungsten carbide, heat resistance, and durability, allowing them to efficiently cut through ferrous and non-ferrous metals like steel, aluminum, titanium, and alloys without rapid wear. The process begins with selecting the appropriate carbide burr based on the burr type, material, and workpiece geometry. Burrs come in various shapes: cylindrical, ball, spherical, oval, tree, pointed or rounded, cone, flame, and inverted cone, each suited to specific tasks. For example, cylindrical burrs with end cuts work well for flat surfaces and right-angled edges, while ball-shaped or oval burrs are ideal for deburring holes, slots, contoured surfaces, and internal edges. Cut styles also matter. Single-cut burrs provide better control and cleaner finishes for heavy material removal and deburring on harder metals, whereas double-cut, or diamond-cut, versions remove material faster with finer chips, suiting general-purpose deburring and finishing on a broader range of metals. Aluminum-cut variants prevent clogging when working with softer, gummy materials. To use a carbide burr for deburring, secure the workpiece firmly in a vise or fixture to prevent movement. Mount the burr's shank, typically 1/8 or 1/4 diameter, securely into a compatible power tool, such as a high-speed die grinder, rotary tool. Ensure the tool operates at the recommended RPM, generally high speeds, 10,000 to 50,000 plus RPM depending on burr size and material, as carbide burrs perform best at elevated velocities for clean cuts and minimal vibration. Start with the burr at a slight angle to the edge or surface, applying light, consistent pressure while letting the tool's rotation do the work. Excessive force can cause the burr to skip, overheat, chip, or break, and it may damage the workpiece or create new burrs. Move the burr steadily in one direction along the edge, often following the contour, to shear off or grind away the unwanted material smoothly. For holes or internal features, a spherical or tapered burr can be maneuvered carefully to chamfer around edges without enlarging the feature excessively. Technique and control are critical for effective deburring. Use short, controlled passes rather than prolonged contact to avoid heat buildup, which can harden the metal or dull the burr. On complex parts, switch between burr shapes, for instance, a tree burr for narrow grooves or a flame shape for weld seams and irregular contours. Lubrication or coolant, cutting oil for metals, is often applied to reduce friction, dissipate heat, extend tool life, and improve surface finish, especially on harder alloys. After initial deburring, finer cut burrs or polishing steps can refine the edge to a smooth, chamfered, or radiused profile as required by specifications. Regular inspection with magnification or tactile checks ensures all sharp edges are eliminated. Maintenance and safety enhance longevity and performance. Clean burrs frequently with a wire brush or ultrasonic cleaner to remove metal chips and debris that can clog flutes and reduce cutting efficiency. Store them properly to prevent damage. Safety protocols include wearing protective gear, safety goggles, gloves, dust mask or respirator, and hearing protection, as deburring generates flying chips, dust, and noise. Secure long shank burrs for hard-to-reach areas, and always balance speed with precision to avoid over-removal or secondary burr formation. In industrial settings, carbide burrs offer versatility for both manual and automated deburring, complementing other methods like tumbling or brushing for high-volume production. Their precision makes them indispensable for achieving burr-free parts that meet strict quality standards in aerospace, automotive, medical device manufacturing, and general fabrication. Proper selection, technique, and care ensure carbide burr tools deliver efficient, high-quality deburring results, transforming rough machined components into safe, functional, and professionally finished metal parts.
Thanks for watching. If you're looking for high-quality American-made carbide burr tools that are built to cut faster, last longer, and help you get the job done right, visit our website today. We keep our American-made Carbide Burr tools in stock and ready to ship, with same-day shipping available on orders placed before our daily cutoff time. Whether you're working on metal fabrication, porting, welding, automotive projects, or precision grinding, we've got the Carbide Burr you need. Visit our website and order yours today.